Okay guys, what do you notice is different from this one compared to the other ones we did? I'm not giving you one radical, I'm giving you how many? Two. And I'm asking you to do what with them? Multiply them. So here is this reversal of this product property of radicals. Now I'm starting here and asking you to put them together and get one radical. So watch what we're going to do. All we're going to do is just multiply the two radicals together. Whenever you have separate radicals, multiply them together first and get one radical, and then we're going to try to simplify that new radical. So what do we do? Which number is outside the radical that we can't put under the radical? 4. Everybody put 4 first out here. Okay? Now multiply the stuff underneath the radicals together. What's 3x times x?
3x squared.
Right, so that's a square root of 3x squared. And now we're going to look to simplify this radical. You first of all put them together first. Do not, I repeat, do not try to simplify this radical and this separately and then multiply them together. You always multiply first and then simplify from there. Does that make sense? Put them together first using this property. Okay? Now, what do you notice under the radical is a perfect square? 3 or x squared. Right, Jack. X squared is the perfect square, not the 3. So 3 is not going to go anywhere. The 3 is going to be under the radical still because there's no perfect square factor of 3 besides 1, and we don't use 1. Okay, so we bring down the 4. We break this radical up into the square root of x squared times the square root of what?
3.
Times the square root of 3. Which one cannot be simplified? The x squared or the 3?
The 3.
So that's going to stay under the radical. But what is the square root of x squared? So cross that out and put an x in place. What can I multiply x by out in front?
4.
The 4, right. So what am I going to be left with, guys? It's a complete answer. 4x times what? And we are done. So same rule applies in terms of simplifying the radical, but you have to multiply them together first before you try to simplify. Let's do another one and see if we can get this one. Here, let's do this one. I'll keep this to only 2 if you guys can get this one, okay? See if you can get this one. Simplify. Okay, how about 2 times the square root of mn squared times the square root of underneath the radical 5m squared. Now this is a little more difficult. Okay, what is not under the radical?
2.
Let's just put 2 out there out in front, okay? Put the 2 out here. Now let's put together what's underneath the radical, multiply those together and put it here. Okay, what number do I put first? 5, so let's put in 5 under the radical. Now let's multiply, remember when we multiply the same basis, what do we do with the exponents? We add them. What's m times m squared become? M to the what? To the, m cubed, m to the 3rd power, right. And what else do I have under the radicals? N what? N squared, good. I'm going to stop there. Does that make sense, or do I need to go back over what I just did? All I did, guys, is multiply these 2 radicals together. The 2 is out in front, and then underneath the radicals, mn squared times 5m squared is 5 m to the 3rd n squared. Now we have to look to simplify the radical underneath, or the stuff that's under the radical. I can't do anything with a 2 right now. So let's just bring that down and put it down here. But I need to separate this radical into separate radicals. What do you notice cannot be simplified under 5m cubed n squared? The 5, because 5 is not a what? Perfect square. So everybody just put the square root of 5 here, because you know that can't be, nothing can be done with that. All right, so I'm just going to go ahead and break that up. Now, but what about m cubed? Actually, guys, how many? I'm going to need 2 arrows there, aren't I? Because is m cubed a perfect square? But does it have a perfect square factor?
Yes.
What do I multiply to get m cubed? M squared and very good. All right, so let's break that up. Let's break the m cubed up into the square root of m squared times the square root of m. I'm going to put it over here so you can see it better, guys. What do I have left? Is that its own perfect square? Yep, so can I just write that as the square root of n squared? All right, I'm almost done. Which one of those 4 radicals can be simplified? Can the square root of 5 be simplified? No. Can the square root of m squared be simplified?
Yes.
Can the square root of m be?
No.
Can the square root of n squared be?
Yes.
You guys got it. All right, so bring down the 2. The 5, now, I'm gonna put the ones that are simplified out here, so don't bring the 5 down yet. What is the square root of m squared? M, so let's put that here. What's the square root of n squared? Now, what belongs under the radical? 5 and what else? And there is your final answer. Okay? This is why we do this in one day, and we do the other stuff in another day. Because, and guys, I know you'll have questions on the homework. I know you will, so I'll explain that tomorrow when we come back in tomorrow. All right. Okay. If this is hard for you, I understand it's not going to be easy, but I want you to try them on the homework, okay? Now, I need to get through the quotient property of radicals, guys, which is the next section, and then that's it. And that'll be all the stuff we have to go over.
How long is that one?
It'll just be a couple examples. It won't be anything more than, it's already what we already know how to do, so somewhat.